Hello everyone, today we are going to learn about the Bresenham's line drawing algorithm, one of the most important algorithms in the computer graphics. In this video, you will understand what the algorithm is and how it works and using a fully solved example. So let's begin. So before diving into the algorithm, let's first understand the challenge. A computer screen is a raster grid made up of tiny square pixels, but a mathematical line is continuous. It has infinite points, no thickness. So the problem is, how do we solve display a smooth continuous line on a discrete pixel grid of pixels? So we must choose the best integer pixels that approximate the actual line. This is where the line drawing algorithms come in. So now you might be wondering why we need an efficient algorithm. The simplest approach is using the slope-intercept form, which is computed by y equals to mx plus b. For every x, we compute a y. But floating point multiplication is slow and expensive. In older computers, embedded system, and hardware drawings, the speed matters. Next came the TD algorithm, which improved performance by replacing multiplication with incremental floating point additions, which is computed by ykx plus 1 equals to yk plus 1. This is faster but still uses floating point addition, causing rounding errors over longer time. So we needed something better, an algorithm that can entirely work with fast, precise integer maths. Bresenham's algorithm was revolutionary because first, it uses only integer, second, no floating point numbers, third, uses only addition, subtraction, and comparisons. Fourth, was very fast and efficient. Fifth, it can be implemented directly in hardware. This is why it's used in graphic systems, printers, and GPUs. Here's the main idea of Bresenham's algorithm. Suppose we plotted a pixel at some arbitrary point, let's say xk and yk. The next position is xk plus 1, and now we must choose between two pixels. Either we have to stay horizontal and plot it, or either we should move diagonally. So we are going to think which is actually which is closer to the actual mathematical line. So for that we use a decision parameter denoted as pk. Its sign tells us what to choose. If pk is less than 0, we choose to stay at horizontal pixel. If pk is greater than 0 or equals to 0, we choose the we choose to move diagonally. This decision parameters update each step using easy integer calculation. Here's how the algorithm works for slope between 0 and 1. First we calculate the endpoints, which starts at x0, y0 and ends at x1, y1. Then we calculate delta x and delta y, which is basically the change in change in x and y, which is calculated by the subtraction of endpoints. Then we calculate the first decision parameters, which is calculated using this formula of p0, which is equals to 2 into delta y minus delta x. Then we write up, then with the help of this decision parameter, we write up the first starting pixel. Then then we are going to repeat the previous step delta x time, and now based upon the value of the decision parameter we've created, we are going to choose either we are going to move horizontally or diagonally. If the value of pk was less than 0, then we are going to move horizontally. If the value of pk was greater than or equals to 0, then we are going to move diagonally. To move horizontally, we are only going to have increment in the value of x, and to move diagonally, we are going to have increment in both the values of x and y, and we are going to update the decision parameter accordingly based upon the previous value of p. Now we are going to learn the Bresenham's line drawing algorithm with the help of example whose starting points are 2, 3 and the end points are 10, 8. Now first we are going to calculate deltas. For delta x, we are going to use the value of endpoint of x minus the starting point of x, which is equals to 10 minus 2, which is going to be equals to 8, and same similarly for delta x, 8 minus 3, which is going to be equals to 5. Then we are going to calculate constants which are going to be used in the algorithm further. For first, we are going to initially third, we are going to calculate the value of initial decision parameter which is calculated by p0 equals to 2 delta y minus delta x which is equals to 2. And now we are going to start plotting at 2 comma 3 since the p0 is 2 which is greater than 0. Then we are going to first move as the initial decision parameters value was equals to 2, which is greater than 0, we are going to move diagonally. For diagonally, we are going to have increment in the value of both x and y. Now, the new value of decision parameter is going to be minus 4. So, we are going to move only horizontally. So, the increment would be only on the x side. And this will go on till the reach the endpoints. And now, the points would be the final plotted points are 2, 3, 3, 4, 4, 5, 5, 5, 6, 6, 7, 6, 8, 7, 9, 7, and 10, 8. So the lines will be plotted based on these points. Bresenham's algorithm is widely used in computer graphics, game engines, embedded system, printer and plotters, graphical hardware, and GPUs. Its speed and accuracy make it preferred choice for line drawing. Thank you for watching. I hope you found this video helpful. This is Kashish Nankani. See you in the next video.